Okay, welcome back to the next part of the video. In the last video, we spent quite a bit of time getting transects set up for our Earth to Venus to Earth mission that we're going to be doing. So now in this video, I want to edit that scenario and just kind of change a few things. What I want to do is I want to use the expert configuration for the XR2. So instead of using the default configuration, I'm going to do the expert one like I did when I went from the Earth, to the ISS, to the Moon, then back to the ISS, and then landed back at Earth. I want to use that same configuration. So we're going to change the ship, and this is actually just the name. So we're going to change it to just XR2 Expert, but it doesn't actually matter what you call it. But we're going to change that everywhere that we see it. And here we got to change that as well. So XR2 Expert. But where it really matters is here, instead of XR2-01, we want to change that to XR2-expert. This is the line that actually tells the scenario file that we want to read the expert configuration. And I also want to scroll down here a little bit. Something that I forgot to do in the last video while I was sitting on the ground setting up transects is we actually want to have the radiator extended. So we want to change that to 1 and then change that to 1. And the reason we want to have the radiator extended is because while we're sitting on the ground, in that configuration, we can't have external cooling turned on because the XR2 thinks that it's basically in some situation like it's in flight or something, so it won't let you have external cooling turned on. And that means that if you sit on the ground too long, I think you got about an hour until the coolant temperature gets so high that it will actually cause a failure. So what I'm going to do to make sure we don't have any problems there is, in the scenario, before I launch the scenario, I'm just going to set the radiator so that it's open so that the coolant temperature is not a problem. Otherwise, down here we need to continue this editing, change that to expert, and this is going to be attached to there, and finally the payload is expert. And note that just changing the word to expert doesn't make it an expert. So if you were to do this in your own scenario, that wouldn't work. The way the expert scenario is being read is it's being read from a configuration file. I guess I can show that real quick. Go to Orbiter, go into the config directory, and I think it's in vessels. No, it's just here. So here this is called XR2-expert. So this scenario file, this line here is reading from this file, and that's how that's how it knows to use the expert settings. And then if we look at the expert file, there isn't much to it. Most of this is just comments, but here we have the main fuel ISP. This is the most important one. It makes it expert setting according to what it says here. It says the with this configuration, you really only got enough fuel to go from landed on the ground up to the ISS, and that's if you use scram ascent. Of course, we're not doing a scram ascent. We're attaching the vessel to the Falcon Heavy, but that's one setting. And then we've got, the locks loadout set to 0, so we've only got 7 days of locks. And we've got the APU fuel burn rate at the maximum. And then we've got require payload bay fuel tanks set to 2, which just is one more thing that just makes it difficult. So that's how the expert configuration works. Okay, so now that we've got our ship set for expert mode, let's go ahead and load that scenario.
All systems nominal.
Okay, yeah, we've got the radiator extended. And let me bring up burn time calculator. Yeah, I've got the low ISP. Normally this would be like 20 point something if you have the ISP, or if you have the main fuel ISP setting at the default, which is 2, then this would be like 20 point something. So now, just need to go over some stuff here. We press F8 to get over to this view. If we come down here and look at our locks, we have 7 days of locks. Now it wouldn't matter really what we had the locks loadout set in the expert configuration if it was, because remember the default's only 14 days. So in any case, in any event, we're going to have more locks. So let's see how long Transx thinks our mission's going to be. And we'll go all the way to the last stage. And we're expecting to arrive back at Earth here at this date, 57006. So we can put that number into a calculator. That's our end time, 57006. And we'll subtract out today's date, 56581. And it's going to be 425 days. So we need at least 425 days of locks. So if we come up here to the scenario editor, or the payload editor, we're going to load it up. We need to do a couple things. I want to take the crew habitat module with me. The crew habitat module does absolutely nothing, has no functionality, but in terms of space flight, it's something that you add to the vessel. There's basically two reasons to add it. Number one, it gives it a more of a sense of realism, because the crew habitat module is basically it's an area of the ship for the crew to work and play in, basically. And if you don't have it, then you sort of think about your crew being cramped up without any area to work or play or whatever it's for. So really, it's just for more realism. The other thing is that it adds more mass to the vessel, which makes your DV cost go up. So it makes it more difficult. But the reason that you would want to add it would be to increase the difficulty of your mission, and by increasing the difficulty, you also, in some sense, increase the realism. So the first thing we're going to do then is add the crew habitat module. And now we have it. We just added 3,384 kilograms of extra weight, and basically it's dead weight. So it adds a sense of realism, but in terms of the simulation, it gives our crew somewhere to work and play. Now let's see. We know that we need some additional locks. Let's see what happens if we add a full tank of locks. That gives us 413 days, which isn't quite enough. Let me close that out for now. Let me bring it back up burn time calculator for a moment. And you can see the estimate for our DV has gone way down. Now we only have 2,000 meters per second according to burn time calculator. And once we get into orbit, we know that we need, over 3,000 meters a second. In order to do the ejection burn to go from Earth. In order to do the ejection burn to go from Earth over to Venus and then back to Earth. So what we can also do, let's do this first of all. Let's just exit here because we don't have anything that much matters. Let's bring back up the scenario in the editor and do just a little bit of additional editing. We know that one LOX module, one full LOX module, doesn't give us the 425 days that we need. So that would mean in order to complete the flight with a full crew, we would not only need one full LOX module, but we would need at least some LOX in a second module. And if we did that, then we wouldn't have any way to bring any extra main fuel with us. So the mission would be impossible. Because if you saw in burn time calculator, we only had 2,000 delta V, and that's just not enough to complete the burn. So what we really have to do here, and I think it's actually more realistic to do this, we need to come down to our crew area in the configuration. And if you think about how many crew would you really take with you on a mission like this in the near future, I don't think we would take 14 crew with us. So if we cut back the crew, let's cut it, down to maybe 6. So all the way these guys. And we'll cut out that many. So we've got 1, 2, 3, 4, 5, 6. We've got 6. We could probably even cut out another one, but let's see if we can get by. Let's see if we can make it work with 6. By cutting out that many crew members, we won't need nearly as much LOX, and we'll also save a little bit of mass, because remember, each one of these crew members they weigh a little bit. So I think the default crew's 14, and we have 6. We cut out 8 people, so over 800 pounds, probably closer to 1,000 pounds or more that we cut out just in human weight. But we also don't need as much LOX now that we've got rid of those people. And there's one other thing I forgot to do, which is we don't need any of the scram fuel. And I believe scram is number 2. So we can toggle that from 1.0 to 0.0, and that'll, these are the propellant lines for the XR2. We want all the main fuel, we want all the RCS, but we don't need any scram fuel. So let's save that. And let's load that scenario again.
All systems nominal.
Okay, now let's look at things. Yeah, we now have 0 scram, which is what I meant to do the first time I did the editing. And now we have, you know, 6 total crew members, because it starts counting from 0. So now let's go to the payload editor. And let's add back in the crew habitat module real quick. And let's see how much we get by adding a half LOX instead of a full LOX. Okay, so we've got a half LOX, and we have 490 days worth of oxygen, and our target was 425. So we've got quite a bit more than we need. That's good. I don't mind having a few extra days. We don't want tons and tons of extra LOX, because that's just extra mass. But what is that? That's almost 70 days. We might actually bleed off a little bit of that, because that's a little bit too much extra. But that helps us out a lot. So by having 6 crew members, we not only can get by with 1 LOX container, but we can actually just use a half of a LOX container, which has less mass. And less mass, of course, means that we have more DV. So now we take a glance at burn time calculator. We can see obviously that we're still shy. We have 2,500 meters per second close to it. That's still not quite enough. So we definitely have to take some main fuel. So let's select the XR2 payload main fuel and put that in container 3, or payload area 3. You'll notice that this actually goes down, and that happens because burn time calculator by default doesn't read the extra payload, and I've mentioned this in several videos, but it doesn't read that payload main fuel as fuel. It just thinks it's dead weight. But we're done with the payload editor, so we can close that out. What we need to do is put that fuel in as extra fuel mass so that we know how much delta V we actually have, and we know that that number is 3350. So we have 3,500 meters per second of delta V. Now there is a problem with this number, and the problem with this number is that it's basing the delta V as if we're going to do all the burning while we're still here in the atmosphere of Earth. And that's our engine ISP here. We actually have more delta V than what we see here. When we get out of the atmosphere of Earth, and remember, we're not going to do any burning on the XR2 until we're up in orbit. So what we really want to know is how much our delta V is when we're in orbit, because when we're here on the ground, this number is a bit misleading. It's a bit wrong. The easiest way to figure that out probably is to just put this vessel in orbit. So let me do this. Let me Control S to quick save. Okay, we've got Transix up here. And we'll use this scenario when we're done for for continuing to set things up. But for now, we're just going to quickly put this vessel in orbit. We're going to use the scenario editor to do that. So we're going to edit the XR2 and go to orbital elements, and then we're going to choose kilometers, and we're going to say, and remember this is from the center of the Earth, so we're just going to say 7,000 kilometers, and then an eccentricity of 0, and then hit apply. And then once we've done that, well, it actually appears as though we're still connected down here, but we can see what we needed to see nonetheless, and that's that we now have 4,398 worth of delta V. This is the number that we need to know. And if we remember from Transx in stage 1, we take our total delta V that we need for the mission, which is 11,570, and we subtract orbital velocity from it. and this is how much fuel, this is how much delta V we're going to need when we do the burn from Earth to Venus. So the difference there is how much we have left over for mid-course corrections. So if we take the total delta V, and really to get a better total, what we should do is take that 3350, let me clear that, and add in our RCS, because we're not going to use hardly any of our RCS for rotation and all that, so we're going to have most of our RCS left over we could transfer it if we need to. So a better extra fuel mass, a more reliable number, is 4154. So we actually have a total delta V of 4,818. So what I really want to do is take that number, which is 4818 minus 3770, and this is how much fuel we're going to have for mid-course corrections, and that should be enough. If it's not, then we're really bad at navigating. Okay, so that's how we know that we have enough fuel for the mission. So let me go ahead and exit out of here. And now we'll go over to that quick save. And we're going to cut that scenario and we're going to paste it into our folder here. And that's going to be part 3. Ship is set up. And anytime we do any file management, we have to close the orbiter launch pad and then start it back up. So we're just going to take one quick look at that scenario.
All systems nominal.
Okay, so we have all the scram dumped. We have 490 days of locks. We have 6 crew. We have the crew habitat module. We have half a tank of locks. And again, before we take off, we may dump 30 or 40 days of locks just to lighten the load a little bit. That'll give us a little bit of extra delta V. And we have 1 full tank of extra main fuel. And we're using the expert mode configuration, so we're going to be burning through fuel at the maximum rate. So we are basically all set up. The only thing that we have to do now is we have just a little tiny bit of final configuration to do in TransX, but I'll take care of that in the next video. So we have to take care of that, and then we just need to wait until it's time to go, because our launch date is actually 5/8/3, so we still have about 2 days to wait. So we'll take care of that in the next part of the video. But I did want to go over the setup of the ship here. It's important because if you just have the default 14 crew, then when you load up your locks, you're going to see that you don't have enough locks just by having one module. So then if you add in the second module of locks, then you can't carry any main fuel with you. And then once you get into orbit, you won't have enough fuel to do the burn to get over to Venus, let alone come back to Earth. So it's really important that we spend at least a little bit of time making sure that we go over the configuration of the ship so that we have everything that we need to complete the mission. If you have any questions about this part, go ahead and leave those questions down below. And I'll see you in the next part where we will finally be getting underway with this mission.